All right, so here's where we're actually getting into the crux of the lesson today. The lesson is entitled Graphing Linear Two-Variable Inequalities. And that's what our whole goal is today, is not just to practice our graphing of linear equations with an equal sign, but to actually get into the realm of graphing inequalities with that inequality alligator crocodile symbol. Okay? So the first thing we want to take a look at is how are these two different from each other? I've given you two equations. Y is greater than negative 2x plus 3. And then over here we have y equals negative 2x plus 3. So let's start by just comparing and contrasting. How are they same? How are they similar? How are they different from each other? Well, obviously we note that this one has an inequality. This one has a greater than symbol. In comparison or versus the equal sign over here. So we have a greater than symbol instead of the equal sign that we're given in the second equation. Now let's take a look at the y's. It looks like the y's are still by themselves. So y is all alone on the left of the equation or the inequality. Looks like we have a negative 2x in both of them as the first term on the right side of the equation or the inequality, which means that we have a negative 2 slope in both situations. Because again, the slope is always the value that is multiplying the x in these bivariate problems. So negative 2 slope in both situations. And then it looks like a positive 3 and positive 3, which means it looks like we're having the same y-intercept as well. In both the inequality and the equation. So same y-intercept, and that y-intercept will be located at 0, positive 3 because of that plus 3 in both of the situations. Okay, so it looks like we have most of the things are in common with each other, and there's just that one little difference of being greater than versus the equal sign in that one. Well, what's kind of cool about linear inequalities and linear equations is that they are the exact same thing, except for two key components. The two key components are that the inequality greater than will always be represented instead of like an equal, let me start with the equal sign. The equal sign is always a solid line. Okay? We draw our dots that are the coordinates, but then we always connect those dots. And we draw arrows on both sides. Right? You've probably lost a point or two here or there for not putting those arrows, saying that it continues on to infinity. Now, the cool thing about inequalities, it could be a greater than or a less than symbol. But if it doesn't have the equal sign that's a part of it, it's always going to be a dashed line. Because essentially what it's saying, the equal sign is saying, yes, all of these are possible solutions. But if it's not actually a solution, if it's greater than or less than, it's not actually going to be a solution. And so we draw our line, though it might have the same slope, we draw it as a dashed line. We don't connect the coordinates to each other. We draw it with sketches or dashes in between them. Now, this isn't true if we have a greater than or equal to or a less than or equal to symbol. Because in this case, we still have that equal sign. So this would fall into the category of solid line again. So that's one of the main differences here, is that no equal sign, but there's an inequality, we have to make it a dashed line on the graph. Equal sign, obviously an equation, or greater than or equal to, or less than or equal to, solid line also. So that's one of the main things that we need to look at today. And there's another key difference, but I'm going to show it to you after we actually graph these two situations. So on the left over here, I'm going to have the inequality, y is greater than negative 2x plus 3, and on the right I'm going to have y is equal to negative 2x plus 3. Now we're going to draw a sketch. Again, this one going to be dashed. This one, going to be solid. We're going to draw a sketch of both of them. Even though it's going to appear as though they are the exact same thing, they are not going to be. So here we go. The first question. Let's go ahead and start with our equation over here on the right. Again, we're going to start with our y-intercept, as we always do. Don't forget your ticks. And here we go. 0, 3 is our y-intercept, and then our -2 slope tells us that we need to make that again into a fraction. -2 over 1, rise over run, which means we're going down 2, and a +1 tells us we're going to run 1 to the positive side, to the right. So down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And again, we're going to go in the opposite direction as well. Up 2, left 1, up 2, left 1. So something right about there. And again, I'm going to go ahead and draw my connector. This is an equal sign, so again, I'm going to make it a solid line. So there we go. Excellent. Over here, we're going to draw the exact same dots, but keep in mind, we're going to make this one a dashed line instead of a solid line when we go to connect them. All right, there we go. And you can be doing this on your paper as well as I'm doing this one. And again, make sure you're thinking ahead of time, especially if you are for some strange reason using pen to do this. I'm using pen so it shows up better on the iPad, but please make sure if you're using pen that you do the dashed line. Oftentimes people make that mistake and then they have to go back through with whiteout and do like every other little section to white it out and make it look like a dashed line. All right, so pretty much the same, right? We got the same exact slope, same exact y-intercept. They look identical with the exception of the dashed versus a solid. So the follow-up questions that I have for you for this question number 66 are, for A, part A,